Okay, in this video I'm going to demonstrate how to graph the cotangent function, and then we're going to take a look at the tangent function as well, and look at several more translations and transformations of those two. So here we go. Let's take a look at the two graphs side by side. There's really a lot of similarities and some differences. Obviously you can see that the gray curves are the tangent curves and the blue curves are the cotangent curves. And the cotangent actually looks like a reflection of the tangent, except for the one major difference is the placement of those asymptotes, because the cotangent is the ratio cosine over sine, and so it kind of takes the reverse role of the tangent. Wherever the sine is equal to 0 is where we're going to have those asymptotes. And if we read off of the unit circle, the sine maps itself to the y value, and so this would be 0, 1, and 1, 0, and so on and so forth. And so right here at these two east-west points, we have the sine value equaling 0, and so that'd be at 0 and pi, and you can see that there's an asymptote here, sorry about that, and there's another one here at 0 and pi. So all of that says there's, again, just quite a few similarities between the two functions. It's just a matter of the placement of the asymptotes there. Yeah, we already made mention of that, so let's move on. So again, here's another side-by-side comparison of the two, and I hope you get my little jokes. This guy is tanning, and there's a cot. Haha. Sorry, folks, just trying to bring some humor into this. At any rate, not very funny, I know. But at any rate, so we see these two curves side by side. They still have the same period of pi units, and again, it's just the difference is the direction in which the graphs are going and the placement of those asymptotes. So if we take a look at the cotangent basics, again, we're missing the plus d here, so we could add that to it. But we have the period is pi over b, same as tangent. The domain is all reals except for multiples of pi. That's where those asymptotes are. The range, just like the tangent, is negative infinity to positive infinity. And the left asymptote and right asymptote are done pretty much the same, except for this time you're going to set them equal to 0 and pi instead of negative pi over 2 and pi over 2. So there you go. And then you can find the midpoints, just like with the tangent curve, and then draw your curves, your basic shape of that. So let's take a look at some transformations and translations. One way of graphing tan or cotangent functions with multiple changes is to rewrite the function exactly, except replace the tan or cotan with cosine or sine respectively, and sketch that sinusoid. Now this is not really the shortcut way, but it is the building blocks for the shortcut way. So I want to demonstrate why we can set that bx plus c equal to the left asymptote and right asymptote. And this would be the reason why. So again, we're going to just graph this function because we're actually looking at a tangent graph, and when the cosine is 0, then the tangent graph has an asymptote. So with that being said, let's just jot down some information about that curve. We know that the amplitude is 3. The period is going to be 2 pi over b, which b is 2. And then interval points will be the period divided by 4. The phase shift, it's been shifted to the right pi units, and it does have a vertical shift. It does have a d value here. So if we were to graph the cosine curve, it would look a little bit like this. And again, those points that are being drawn right there, they have intervals of pi over 4. And the bar's been raised up 2 units. And you can kind of, there's the shadow of the cosine curve. And you can see that when the curve hits that blue bar, that's where you're going to have those asymptotes. And then halfway in between those two bars is a zero of the function. And then again, since we're doing tangent, we're going to sketch it in this direction. It's not real necessary to take the midpoints of the midpoints like we did in a previous lesson. That was just to put some things in stone and cement up some stuff. But generally speaking, when you draw these curves, you just have to get that midpoint and then trace the graph as it behaves towards the asymptotes. You can do multiple cycles as well. Okay, another way of doing this one, exact same graph, except for this time we're going to set the left asymptote equal to negative pi over 2 and the right asymptote equal to pi over 2. Now I want you to notice that I did have to distribute this 2 into the equation because it's bx plus c. So when you're doing these, the b value has to be inside the parenthesis with the x. So that would explain that. And then we want to put those asymptotes up and construct the bar at 2. And then we can, again, have the same exact curve as what we did before. You can do a few more if you want to. Again, how did I get that 7 pi over 4? Well, I noticed that the difference between the left asymptote and the right asymptote is pi over 2. And so I just added another pi over 2, which is 2 pi over 4 to the next one. So the next asymptote could be at 9 pi over 4. Let's take a look at a few more examples. On this first one, again, there is no amplitude, but that 4 just tells us that the graph is growing a little bit quicker than the others. The period is pi over 2. So our left and right asymptotes can be found by setting those equal to negative pi over 2 and positive pi over 2. And there's the graph. And as you can see, that's pi over 2 between one endpoint and one asymptote to the other. And then you can construct your asymptotes, find the midpoint. And I just, again, for demonstration purposes, to show you what that 4 does, it just really stretches that, makes that graph grow a little bit faster than normal. We know that, again, 2 theta, if we were to take 2 theta, which is this point right here, that would be pi over 8, because halfway between 0 and pi over 4 is pi over 8. If you double pi over 8, you get pi over 4. Well, that's tangent 45 degrees or tangent pi over 4, which we've already said is 1. So when theta is equal to pi over 8, the y value is going to equal 4, because that's going to be 4 times 1. So again, that's just to show you what that 4 is doing. It's not an amplitude or anything, but it does show that the graph grows quicker. And you can just sketch the graph from there. Let's look at the next one. This one, I'm going to show you a couple different ways. Again, we can use the cosine curve to help us trace this graph. Again, you kind of have to know a lot about transformations in the cosine. The interval points will be 3 pi over 2 units apart. And for the cosine curve, it does have an amplitude, so there would be a partial graph of the cosine curve. And again, where you have those zeros of the function is where you're going to have your asymptotes. I just drew another point on the other side of the y-axis as well. Again, the difference between these two asymptotes is going to be, well, they're going to be 3 pi. So there you go. And then you can just find the midway point and do it again, and you're done. Let's take a look at a cotangent. No, I'm sorry, we're going to do this using the shortcut way. So again, with the period for the tangent curve is going to be 3 pi. The left asymptote, that was obtained by setting this whole thing right here equal to negative pi over 2 and solving it. And the right asymptote, again, will be done in like manner, setting it equal to pi over 2. It's getting kind of close in there, but you can see I just added pi over 4 to both sides. And so my right asymptote is at 9 pi over 4. Again, these numbers should look familiar. Halfway in between those 2 points is 3 pi over 4. And we can put our asymptotes up and draw the curve. Alright, so let's move on and take a look at the cotangent. The cotangent, the period of this graph is going to be pi over b, or pi over 4. The left asymptote we're going to set equal to 0. Remember, the asymptotes are in different locations for cotangent. And so the actual left asymptote is going to be at 0. And the right asymptote is going to be at pi over 4, because we set the right asymptote equal to pi. And so now when I construct this, I can put up several asymptotes. The bar has been raised on that one. Let me stop that. The bar has been raised to +1, so again, you want to find halfway between the distance on that bar, and then just draw your cotangent shape. The next one is, it's already been started. Again, we can actually do the sine curve on this one. Take a look at the sine curve. And as we construct the sine curve, we notice a lot of things about it. Oh wow, that was fast. Let me back that up. That was a little too fast. I'm going to slow that down. So again, this is the sine curve that's being constructed, and let's just stop it there for a sec. You can see that the amplitude of this is 3, so that's why from the bar we need to at least go up 3 or down 3 and give enough space. You need to mark your y-axis with appropriate markings. You notice that after I factored out a 3, the phase shift is to the left pi over 6, so that's why I started at that negative pi over 6. And I am creating new interval points. As you can see, they're pi over 6 units apart. That's what the IPs would be. And then there's the sine curve. Wherever you have zeros of the function, you're going to have asymptotes, and so you can see that the asymptotes have been constructed. And then halfway in between those 2 points, those asymptotes, excuse me, you're going to have your curve. Okay, and of course we know that there is a much quicker way of doing this, and just set that left asymptote equal to 0 and solve, and set the right asymptote equal to pi and solve, and we get the same exact graph as before. And so that does conclude this video. I hope that you now know how to graph the tangent and the cotangent curves without any problems.